right. So our group is comprised of Bianca, Juliana, Ben, and myself. And our title is Lower Extremity Blood Flow Restriction and its Effects on Squat Jump Performance. So first thing with this presentation, we'd like to go over the goals of it. First being to give some definitions of our main 2 points here, especially that being post-activation potentiation and blood flow restriction, which you'll see in the slides as PAP and BFR shortened there, and as well as just give some background information on the research we did and what we'll kind of be looking into, which will then mainly be by investigating vertical jump performance in relation to different conditions pre-jump that will then affect the actual vertical jump test. And thirdly, to go over our study and then to discuss its findings, its limitations, its implications, and kind of the future direction of all of the research that we're going to be going over. So next, we'll talk about our target audience, mainly, we think this information can be useful for coaches and athletes, as multiple sports such as football, basketball, track and field, volleyball, all use vertical jump as a measure of performance and often test them in the competitive level. And so we hope that our study and our research here will be helpful for them mainly. Also physical therapists, and especially as we're using the blood flow restriction style training, that is something that physical therapists have more recently worked into clinics, working with certain patients post-surgically who just can't have that traditional, amount of load exerted on their body yet. And so especially for athletes recovering, this could be useful for physical therapists. And then finally, thirdly, for researchers and exercise scientists, this is useful as our study was a pilot study, and we hope that it'll be kind of further carried on using different variables, using a much larger sample size. And so that is where the exercise scientists and researchers can come in.
All right, so the plan is to define the terms of vertical jump, PAP, and BFR. We're going to look at prior investigations of PAP and BFR on both muscular and jump performance. Then we'll understand what the purpose of our study is based on those prior investigations, and then how we did the study, the results we found and what they mean, some limitations that our study had, and last but not least, the many different directions that further investigation can expand on this idea. So for defining terms, let's start with vertical jump test. The primary goal of the vertical jump test is to reach the greatest possible height, which is a function of explosive power and vertical velocity. A lot of studies have looked into what variables provide the best vertical jump performance, such as strength, speed, power, and coordination. And a study done by Dowling and Vamos on this exact subject concluded that peak positive power and vertical jump ability have a really strong positive relationship. So when athletic training targeting should target muscular power and rate of force development in order to help with increased jump height. And there are two types of jumps that are commonly used in this type of test, but they differ slightly in the type of demand they have on the body. So the counter movement jump, the participant starts in a standing position, initiates a downward movement, and then immediately it's followed by an upward movement, which is the takeoff. And there's a utilization of the elastic energy in the counter movement jump, since there's a stretch reflex that occurs and a bounce of elastic energy when you hit the bottom of the squat to the takeoff. So there's a greater uptake of muscle slack and buildup of high stimulation. And this type of jump really provides info on the reactive strength of the lower limbs. Whereas the squat jump, the participants, they descend to a stationary squat position and then hold it for 2 to 4 seconds before they actually take off. So this is going to minimize the elastic effects that would happen usually from the counter movement. And the resultant jump is correlated more with explosive strength, speed, agility, and power. And then it would provide more info on the leg power performance during the concentric movement, which is the upward part of the squat. Then you can get the video. So start from the beginning to 9 seconds. This is going to be the counter movement jump. So just kind of an immediate descent and then ascent, and then you can go to 29 seconds for the squat jump. See, they held it for 2 seconds when they got to the eccentric part of the squat. So we chose the squat jump over the counter movement jump to minimize any elastic effects from counter movement. That way we can focus our interventions on affecting the power performance generated during the concentric movement, which is the upward phase of the squat. And then this also allowed us to standardize how low we wanted the participants to squat to, and then how long they each were going to hold it, so that it was going to be like the same type of protocol.
So next is defining post-activation potentiation, or PAP is defined as an increase in the contractile ability of muscle fibers after muscle contraction occurs. This increase in contractile ability can lead to explosive force. For example, when an athlete jumps, although the exact way in which PAP occurs is not completely understood, it has been suggested that PAP contributes to phosphorylation of myosin regulatory light chains, increased recruitment of higher order motor units, and the possible change in pentation angle. Athletes use the principles of PAP to enhance athletic performance by using heavy resistance exercise prior to performing counter movement jumps. Now, blood flow restriction is defined as is a rehabilitation tool used by physical therapy patients and athletes. BFR training is a technique involved involving the use of tourniquet style cuff applied to the limb. It can be either on the arm or the leg. Muscular strength and hypertrophy can be improved by combining BFR training along with load resistance training.
All right, so next we'll go over some prior investigations, which basically is what we looked at from the current research and literature on these topics that we have now defined. And so first we'll start with PAP. The main consensus is that it has been shown to increase jump height in vertical jump tests when compared to not doing a loaded exercise before the actual jump test. So comparing it to baseline more. And I'll first say that different studies have shown it effective in counter movement jumps and in squat jumps, as we looked over both of those. And so that gave us reasoning to even use it for a squat jump in the first place. And as Ben said, it is initiated by a pre-jump loaded exercise. So this is generally doing a certain exercise a few minutes before, a relatively short amount of time. before the actual vertical jump test with some sort of load on your body with, resistance training. And then effects have been seen in the research, mainly as increases in jump height and in force production or in impulse, although there are also other effects that could be seen. And again, this is in differences between a jump using that loaded exercise before doing it and then not exercising at all or doing maybe an exercise with no load. That is where we have seen differences in the jump effects, such as force, jump height, and then possibly to a lesser extent, velocity and acceleration, which is not as well proven, but Bianca will get into more of the specifics regarding the pre-jump part of the loaded exercise.
Right, so with the research, they were showing that the traditional training load, the number of reps and the rest time all have their own effect on jump performance. Training with heavy load, about 80 to 100% of 1RM, and then performed a few times with longer rest periods induced greater muscular power. Go to the second one. The greatest PAP effect after a longer rest period of 5 to 7 minutes and 7 to 10 minutes were seen in trained individuals, and then 3 to 7 minutes for athletes. And this was compared to rest intervals of only 2 minutes. And the literature suggested that the concept of fatigue and potentiation can coexist. So performance increases if the potentiation offsets the level of fatigue produced by the condition. And with a shorter rest interval after a high intensity bout of, say, like loaded back squats, fatigue may dominate and reduce the ability to express PAP. So it's important to give enough time in order to realize the greatest PAP effect. Overall, the literature had showed that traditional high or moderate conditioning activity, at least 5 minutes should be weighted to get the greatest PAP effect. But on top of that, the training of the individual also played into effect. A lot of research has been reporting that athletes or stronger individuals can realize greater PAP effect from 3 to 7 minutes, as you can see in the picture below, where the peak is. That's in the athletes, whereas the peak for the trained individuals was a lot later. And their suggestion is that athletes need less time in order to dissipate fatigue, whereas weaker individuals may need more time, at least 8 minutes, to get to that like realized greatest point of PAP.
All right, and then our third and major area of investigation was on more of the BFR side of things. And we mainly found studies using that roughly 25% of the 1 rep max load when using BFR. And it has often been seen to increase hypertrophy or muscle growth, as well as strength in a multitude of different populations, age, gender, etc. And next, we were looking at what percentage of occlusion, as there have been studies, also looking over a large number or different ranges of percentages of occlusion. And relatively more is better in that it is more optimal to elicit the most muscle growth or strength gains. And so this is just some of the reasoning as how we came to what we used in our own methods for our experimental study. And then thirdly, BFR exercises have also shown similar levels of muscle activation compared to traditional resistance training. And so this was done using EMG, such as we have in the lab, similar, and shown similar levels, sometimes lesser or more. And this isn't something that we get into exactly in our study, but just another way to show that BFR does have its similarities with traditional resistance training. And so that kind of gives us reasoning for how we did things the way we did them. And that will lead us to our purpose and kind of gives you the thought process behind what we are doing. And so the purpose of our study is to develop reproducible methods for future studies to examine the potential effects of blood flow restricted squats on post-activation potentiation regarding the squat jump movement. And that is a mouthful, especially without the abbreviations in there for our two main terms. But basically, since we did this experimental study with only 3 participants, we're not claiming to prove anything with our data, with our findings, but in making the methods, in doing this study and looking over these things, we are preparing the way for future researchers as a pilot study to just look into these ideas further and hopefully to make the argument that it is worth looking into to allow for that.
All right, so for our methods, we had 3 college-age participants of mixed gender that were recruited from the EXS 4715 course. They are all physically active, but they're not specifically trained. And then all the participants were familiar with the movement of a squat jump, but they weren't specifically jump trained. You can get the table. So what qualifies us to be able to use these 3 participants was that they're about the same age and height and all within the normal range of cardiorespiratory fitness. So as you see in the top blue box, it's showing the typical participant characteristics. The middle green box was the cardiorespiratory fitness of the participants. And then the lowest purple box was showing the baseline squat measurement, which we had to take in the beginning, and it'll be further explained and used in the rest of the methods. But as seen as in red, the weight and the 5 RM squat amount definitely did differ between the participants. So this is a factor that our participants are not fully alike, but and it will make the results a bit difficult to interpret. Seen with the, you can go back, sorry. The asterisk is just showing that the Queen College Step Test was used to assess the cardiorespiratory fitness, and the protocol was the one used by the ACSM guidelines. And then on top of all this, of the baseline measurements, we also explain the risks of the BFR to each participant, because it's been found very low incidence of blood clotting, which is important for anyone who has a known blood clotting issue or is on birth control that might be at higher risk. And also BFR has been found as unaccustomed exercise is typically and generally known that delayed onset muscle soreness will be found about 24 to 72 hours. It'll take for it to go away after the exercise is done. And especially if it's a large amount of eccentric actions, which is what we have going on with our squats. And then the jump protocol was explained to each participant. And before we even started the study, each person was able to practice 5 times on the force plates in order to familiarize themselves with it. Since, as we know, with motor learning, improvements happen through practice of our skills. And we didn't want that after, if they didn't go through it, we didn't want from trial 1 to trial 2 to see this massive improvement and it possibly be from the learning effect. So this way we were kind of reducing that learning effect from occurring. Go ahead. So as mentioned in the previous slide, we had to measure each person's 5 RM. The ACSM protocol was used with the addition of a warm-up that included 5 back squats with a 25-kilogram barbell and then 2 minutes rest before we started the test. The reason why we did the 5 RM was because of participant safety. And then we were able to estimate our 1 RM through the exrx.net website. And we needed this because we need to get weight percentages for the experimental conditions. After we did the 5 RM test, we did wait 1 week fully in order to make sure that none of the participants had any muscle soreness. So for the conditions, the testing sessions were assigned on a Monday, Wednesday, and then the next Monday for no particular reason. All the sessions were held in the morning at 10 a.m. to 12 p.m. Condition 1 was 1 set of 5 back squats with traditional loading, so 85% of each person's 1 RM. Condition 2 was no intervention at all. Condition 3 was 1 set of back squats with BFR load, which was 20% of 1 RM, and the cuffs were occluded at 80% arterial. So Condition 1 and 3 were assigned randomly in order to reduce order effect, meaning that we didn't want the order of the experimental condition to actually be the one affecting the outcome variable and not the intervention. However, condition 2 was specifically assigned as the second testing day for all participants because we didn't want test day 1 to be super close to test day 2. And if a person was assigned a different condition, fatigue may have taken place and still been in effect from trial 1. So that's why we had condition 2 assigned the same for all. But before we even did start condition 2, we had the participants self-report if they had any feeling of muscle soreness, and none of them reported any. All right, so for our methods, we started with a warm-up. The speed was increased to 3 miles an hour on the treadmill, and then the participants started their 5-minute walk. After this, they walked to the squat rack and they waited 2 minutes standing. There's an asterisk there to say that during condition 2, which is the one with no squat intervention, the rest period was 2.5 minutes instead of 2, like it says there, just because we had to make it 30 seconds longer since there was no squatting condition being performed. And then also during the rest for condition 3, if someone was doing the BFR condition, that's the time when the participants put the BFR cuffs on their thighs. And they were inflated in the last 30 seconds. So for the protocol, for the traditional and BFR condition, as mentioned before, back squats were performed 1 set of 5, and it was done in under 30 seconds. The participants squatted to parallel, so knee flexion angle to 90 degrees, while someone behind them and to the right of them watched to make sure they hit parallel. After the bar was re-racked, a 7-minute timer was started. And if the participants were doing condition 3 at that time, so the BFR cuffs condition, they had to take the cuffs off at that time. The participants walked from the room where the squat rack was to where the force plates were and the motion capture system. And the participants stood in front of the force plates waiting for the timer to go off. You can go to the next slide. During this time, the joint markers were put on the participant so that the cameras could record the joint angles throughout the squat jump. And we had 5 of them on the shoulder joint, greater trochanter, knee joint, ankle joint, and then the 5th metatarsal. You can go to the next one. So once the timer was up for the 7-minute rest, the participants stepped onto the force plate with feet shoulder width apart and hands on their hips. And the technicians counted down 3, 2, 1, and the participants squatted to parallel while another person counted out loud 2 seconds. They maintained that position for 2 seconds, and then the participant jumped as high as they could, and then returning back to the force plate. The hands on the hips were done specifically to reduce any arm swing effect on vertical jump, since it has been found that it does increase vertical jump height, and multiple studies use the hands on the hips way. And then also the 2-second pause was used, as many studies have done when using squat jumps. Just some additional comments about the warm-up. It was really important that the warm-up was done because a lot of studies that were doing similar things with BFR or with squat jump, they had no warm-up and instead the intervention. So the 1 set of 5 back squats was the warm-up to them. And the problem with that is that low intensity warm-ups or short bouts of squatting raises muscle temperature, which has shown to increase jump performance. So by doing the squats and then the jump, you kind of have a slight guarantee that there will be an increase in jump height, and you can't pinpoint exactly if it'll be from the squat intervention or from the increase in muscle temperature. So it was important for us to, in all 3 conditions, raise each person's muscle temperature and then put the intervention before actually doing the squat jump trial. Play that video.
3, 4, 5. Good.
Well, I can just find her another class. Okay.
Just let me know parallel.
Yeah.
Good.
What do you think?
Good.
So Thursday, we're doing a study back at the gym and everybody's doing.
Yep.
Sir?
Are you ready?
I'm ready.
Ready.
Go.
1, 2. Nice.
Nice.
All right, and then for data analysis, the measured values we had from the force plate data and from the motion capture system, we had force, peak force, time in air, peak knee extension, velocity, and acceleration given from those. And then the calculated values we did ourselves was body weight, takeoff velocity, jump height, and impulse.
Okay, so the first thing we got from our data, the squat angle relative to horizontal with BFR is greater. So our data is not significant, like no significant difference between the conditions. And this is because we had like all of our participants are close and like they're active and their age is close. And also we had just 3 participants. So based on the 3 participants, we had to stimulate our data to have 21 participants instead of 3. So we multiplied the data of 3 participants by 7. So we got like more significant difference between traditional pace and BFR conditions. So based on that, we had the BFR, the squat angle with BFR is greater than other 2 conditions. Same here for peak force. So as I said, we stimulated the data to 21 participants. The minimum number of participants we can have to see difference between conditions is 9 participants. So same thing here, PFR and the like peak force with BFR is greater than other 2 conditions. Okay, so vertical jump height, as we did for peak force and squat angle, we got vertical jump height with BFR is greater than the traditional and pace conditions. Okay, so for impulse here, we found like a decline and the impulse was BFR. And as I mentioned that we had peak force greater with BFR. So here we can say the impulse had changed by the change of time. We're gonna discuss that in discussion form. Okay, so for our like P knee extension acceleration, we got it's a greater acceleration with BFR condition, and like comparing to other 2 conditions. Okay, so we're gonna discuss the stimulated data, why we did that, the t-test values, and yeah, and see if it's significant, more significant after stimulating our data. Why did the squat angle of squat jump become more shallow after the BFR condition? Why we got smaller impulse with BFR compared to traditional and the baseline conditions. And as I mentioned, is it because of peak force or the time difference between the initial time and the end time of the squat? How was the jump height affected by that? And we are gonna go over greater average peak knee extension acceleration with BFR condition. And yeah, you can go. And also for that, we can say that muscles most activated during peak knee extension acceleration, so BFR, caused greatest muscle activation. That's why it's an explanation why we got peak knee extension acceleration with BFR like higher than other two conditions. And we're gonna go over why we got larger peak force with BFR conditions. So for our results, we have found that the squat angle is greater in the PFR condition. That means that the depth of the squat is less than other two conditions, and the squat is more shallow than other two interventions. No studies was conducted to examine why the reason of having shallow squats after the use of PFR, and we need to do more research on this particular topic. But our idea is that they got more shallow squat after the use of PFAR because of muscle fatigue, but no scientific paper support that yet. There was no you can go back. Yeah, there was no significant difference in our original data between the traditional base conditions and the PFR conditions. So as I mentioned, we stimulated the data and assumed that we have 21 participants, and we repeated the data of the 3 participants 7 times for more accurate results. Upon stimulating our data, the t-test and p-values get closer, and they are both less than 0.05. That data means it's statistically significant, and there is an effect of BFR on the squat angle. You can go on. Okay, so for the impulse, we noticed that the impulse with BFR is less than the traditional load and baseline conditions. As we mentioned, impulse is the product of multiplying the peak force by the change in time of the squat. And since the peak force was greater with BFR, so we can conclude the impulse was affected by the time of the jump. The duration of the jump squat was with BFR was shorter than the time was taken with the traditional load and the base no load condition. We can say that muscle fatigue after the use of BFR caused shorter jump squat duration. On the other hand, we see the lower peak force with longer time resulted in higher impulse values. Impaired impulse or low impulse values can be caused by many reasons, like the lack of neuromuscular control, inability to perform a good and full jump squat, and lack of attention and distraction. Based on our data, we can say it is because of time difference, but more research should be done to statistically examine why impulse is lower with the BFR condition. Okay, so for vertical jump height with BFR, same thing, our study showed that slightly difference in the vertical jump height between conditions. The vertical jump height is slightly greater with BFR than other conditions, especially with the traditional resistant training. So we don't actually see significant difference between vertical jump height with BFR and the traditional vertical jump height with traditional resistant training. But when we stimulated our results and we had more and different participants, that let us see like a significant increase in vertical jump height with BFR. As seen in figure 2, the peak force is greatest in the BFR condition. And as established in the beginning, peak power is a major determinant of vertical jump height. So we have power equals force times velocity. So this increase in peak force occurring during the squat jump trail after the participant went through PFR condition may be explanation for why the participants jumped higher. So as I mentioned, for peak knee extension acceleration, we had higher and greater results with BFR. And this is because of muscular activation after the use of BFR is greater. So we can see that the acceleration with BFR is greater. So our limitations, we actually found it's difficult to interpret results because we actually had 3 participants and they're all were at around the same age and they're active. So it was difficult to interpret results because results were like no significant difference between them. So this was one of our limitations. Like, as I mentioned, they were around same body weight, training experience, and 5 RM squat and squatting conditions were all the same. We didn't have any different interventions and different characteristics of our participants. So that's why it was difficult to see any significant results. Okay, the time frame of producing the study, we just went 3 times, like 2 times a week, 3 times for each condition. Actually, no. So we got 3 times, we attended 3 times, like Monday, Wednesday, and Monday of the next week for just 2 hours to do our study. So actually it was one limitation. We didn't have much time to work more on each condition to see if there any difference, because we didn't actually see if the participant had like any power drinks like Red Bull, any caffeine in each day. So that's why. So third thing, inexperience of researchers. It was our first time to conduct a study on the BFR and its impact on the vertical height jump and squat angles. So this was our limitation too for that.
So another limitation we had was that our true 80% and 20% of 1RM wasn't actually used for the participants in the conditions. And it was because we had to round down depending on what weights we had available. So if someone's percentage came out to 181 pounds, we had to give them 180 pounds to squat for their condition. So technically it wasn't the true value. There was no redo of the jump trial. So for one of our trials, the jump protocol wasn't followed correctly. So we had to delete those results. And instead we had to average the results from the other 2 participants on that exact trial. And it was reasonable because the participants were similar in characteristics. But this was a limitation since our protocol only allowed for 1 jump trial to be taken and no redos. Because you couldn't jump a second time and then take that one since it's not the first jump out. And we couldn't have the participants redo it at a later time by redoing the condition, because then the condition orders 1 and 3 were randomly assigned. So therefore, by them doing it later, it would completely make it not randomized anymore. So we didn't have the ability to have anyone fail basically a jump trial, and that was a definite limitation and could be, you know, consideration for future. The squat to parallel, the only way that we were able to confirm this was by really eyeballing it and in the moment and verbally telling the participant to adjust if they needed. But as we saw in figure 1, clearly with the BFR condition days, the participants didn't squat fully to parallel during the squat jump trial. So this definitely was a limitation that we didn't fully follow our protocol, and a better way should be implemented for future. And then, as Juliana mentioned a bit earlier, there was no control of the caffeine consumption, amount of sleep prior to each test session, and then either if like the participants did any resistance training outside of the investigation during that time.
Okay, so for future investigation, we need to have more participants for our next study, so we can just make our results more accurate and see if our results gonna be supported by that, like by increasing our sample size. So we need also to explore different loads, occultation repetitions to induce PAP, since we only use the 85% of 1RM for the traditional resistant training and just 20% of 1RM for BFR with occulation of 80%. So we need to see different loads, occulation repetitions, and see if there are any difference in our results. So we need to include on our methods a way to make sure the squat is performed to parallel, because it wasn't measured, and it may be like a limitation for our study. So we need to make sure of that next time we do our study. So we also need to test the impact of BFR on hip replacement participants to test whether the BFR helps with the rapid recovery or not for the hip replacement patients. And if we can use this in physical therapy clinics and see if it's effective. Second thing, we need to test the knee angles while squatting with BFR on and off. It wasn't measured in our study, and it may be a limitation for our study, so we need to make sure of that next time we conduct a study with BFR.
Our study solely focused on college students, so further investigation could be done, say in like older individuals in like 30s and 40s, to see if there's a significance with the age, or is it still based on training level, or both. And then for the 0.7 and 8, they go kind of together in a way. As mentioned earlier, prior investigations found that different levels of training affected the rate at which fatigue was dissipated, so the rate at which they realized the greatest amount of PAP, and then also that the type and intensity of the condition had an effect on it, so how much time they had to wait in the rest period. Since there is no set standard at the moment in research, like how much someone should wait, depending on, there's so many factors that really like go into it. So further investigation could be done with recreating the BFR condition with the participants of different levels of training, so untrained, trained, and athletes, and putting different rest times to see, what we'd find. And last but not least, all the previous research, as mentioned before, was done only with traditional loading, so with the high amount of weight on the back squats, but no research has been done on BFR loading and what rest times would work for that type of training. So definitely a further direction for investigation would be going through BFR loading and seeing, is it similar to traditional loading? Is it different? How do the rest times change with that type of loading?
All right, thank you all for listening. We did just want to put this slide in here as a couple points. If you forget everything else, as we went over a lot of material, a lot of different kind of avenues with it, that this pilot study kind of allows for and encourages much more research to be done regarding all these questions, the limitations, the different directions that this study could also go in. And of course, our experimental study doesn't prove anything in and of itself, but we hope that it showed some potential for full findings and just different avenues, as I said, that we could take here. Here are our references. And does anyone have any questions?